Alright, good day everyone. I will be looking at projectile with angle of projection. Just like projection motion without angle of projection, projectiles with angles of projection also have two motions. But in this case, we rather say two components. In my last video, I talked about the vertical component and the horizontal component. And we said that the horizontal component is Vx and the vertical component is Vy. The formula for the vertical component is Vx is equal to u cos theta, and the formula for the vertical component is Vy is equal to u sin theta. U will be referring to the initial velocity. It is important to note here also that the horizontal component of projectile motion is constant, but the vertical motion varies because vertical motion is subjected to gravity. Now, I'll quickly show you a video, and I said in my last video, pay attention to the green arrow and the red arrow. The V you see in the video is the resultant velocity. This resultant velocity has two components, the vertical component and the horizontal component. The horizontal component, just like we had, is always constant, but the vertical component changes. So we look at this video to quickly see the motion of projectiles when an angle is involved. So guys, watch the video and pay attention to the green arrow and the red arrow. So I will play that again for you to see. You observe that the green arrow is reducing as it goes upward. Then when it bends downward, it is increasing as it comes downward. This is how projectiles move when they are inclined at an angle of theta. Now this is another video showing the same thing. Observe the ball as it goes upward, while Vx is tending to a constant value 0. At maximum height, Vy is 0, while Vx is still constant. Then Vx, the ball moves and it gets downward. This is how projectile motion is. Okay, so that's it again. Vy tends to 0. At maximum height, Vy is 0. Alright. From the two video clips shown, it is clear that the vertical component of velocity is 0 at maximum height. Now please, that information is very crucial when discussing projectiles, when an angle is involved. At maximum height, vertical component of velocity is 0. But the vertical component of velocity decreases to 0 as it gets to maximum height, and increases as it goes from maximum height downward. I don't know, want to have some fun? Then check out the activity in the next slide and put it as things you will do before you get to 50. Now I'm going to do some crazy stuff before I get to 50, so I don't know what your own list is. Now check this one out. That's some activity right there. You might want to try it again. Alright. Now, discussing projectile motion, this is how it is. Our Ux or Vx is always constant. This is all constant. While at this point you have mass, that is where we have Vy to be equal to 0 in the last slide. So Vy is equal to 0 at this point. Also, at this point, Vy or Uy is decreasing. It decreases until it gets to 0. But it will increase vertically downward when it's going to the ground. Okay. So, that's just it. Now the terms used in describing projectile motion are time to reach maximum height, time of flight, maximum height, range. The time to reach maximum height, it means just what it says. It is the time for a projectile, it is the time a projectile takes to reach its maximum height. It will interest you to know that the time of flight is also known, the time to reach the maximum height is also known as the time of ascent. So please, it is the time to reach the maximum height. This is not time of flight as it is written here. It is the time to reach maximum height. It's also known as the time of ascent. According to what we just said, the time to reach maximum height will be the time it will take a projectile to leave this portion to get to this portion. That is the time to reach maximum height. And the time of flight is the time it will take a projectile to leave this portion until it gets to this portion. Well, plug this component into the horizontal, into the equation of motion. I'm going to have eventually sin theta over g. That's because the initial velocity u is now a vertical component u sin theta. As it is subjected to gravity, our at becomes gt. So finally, at maximum height, our time of flight or time of ascent will be t is equal to u sin theta. So please, you can take note of that in your notebook and use it eventually. Alright. The time of flight is the time it takes for a projectile to reach the plane or level from which it was projected from. So time of flight is 2 times the time to reach maximum height. In our last slide, we saw that the time to reach maximum height is u sin theta over g. So the time of flight is 2u sin theta over g. I believe you know that theta is the angle of inclination. So like I said in the last video, the time of flight will be the time it will take a projectile to leave this point, get passed through this place, then to the ground. So it is important that you know the definition of time of flight, especially if you want to be a soldier and you will be releasing missiles to the enemy's camp. Maximum height. This is the highest vertical distance reached when a projectile is projected. And if we plug in the components of velocity in our original motion equation when an object is under gravity, then we'll get h is equal to u squared sin squared theta over 2g. Now we have other ways of writing this formula. You can write it like this, or you can write it like this. Now these two are, this last one is very, very popular. You can also write like this, h. So you can put that in your notebook, especially when you are calculating. U squared, open bracket, sin theta all squared. Oh, that's taking time. That's taking time. Divided by 2g. So when you are calculating, this would be a very good way to write your to bring out your values. Okay, now that you have learned that, then let's see range. This is the horizontal distance from the point of projection to the point where the projectile hits the projected plane again. And range is the vertical, the horizontal component of velocity times the total time of flight. So if I plug in those values in the equation, eventually we'll get r is equal to u squared sine 2 theta all over g. Maximum range is attained when the angle of projection is 45 degrees. Please, that is an important fact to note in physics, that to attain the maximum range, the angle of projection must be 45, sorry. Why 45? Let's check it out. When we plug in 45 into the equation of range, we are going to get u squared sine 2 times 45. 2 times 45 will be 90. Okay, divided by g. Now in trigonometry or in your mathematics, sine 90 is 1. So eventually your maximum range will be u squared all over g, just as it is written in our formula. Now to know maximum range and the formula for range, we can go ahead to solving questions under projectiles when the angle of projection is involved. So example 3. A projectile is fired with initial velocity 150 meters per second at an angle of 30 degrees with the horizontal. Calculate the time to reach maximum height. Number 2, the time of flight. Number 3, the maximum height attained. And number 4, the range. Since you have the formula, you just plug in the values and you get your answer. Now for this question, our angle of projection is 30 and our initial velocity is 150. So when I plug in 150 for you, when I plug in 150 and 30 for the angle, we will get 7.5 seconds. If we take g to be approximately 10. But you and I know that many times we take g as 9.81. But to get a round value, you can approximate to 10. Okay, the total time of flight will be 2 times the time to reach maximum height. So you can just do it like this, or you do it like this. So if you do it like this or like this, you'll be getting the same result. And the final answer to that question is 15 seconds. So also h u squared sine squared theta over 2g. Now please, with your calculator, it will be better you solve it this way. 150 squared, just like I showed you in the last slide. 150 squared, bracket open, sine of the angle 30, sine of the angle 30, all squared. And it will be very easy to complete this way with your calculator. So you punch sine 30, then you square the value, then multiply by 150 squared, then divide by 2 times g, which is 20. If you press your calculator very well, eventually you should get 281.25 meters. 281.5 meters. Finally, the range is u squared sine 2 theta over g, which is equal to 150 squared sine 2 times 30 divided by 10. Now, when you finish your plug in and you use your calculator, you should get 1948.56 meters. Okay, so let us check the last question for this class. A particle is projected with a velocity of 20 meters per second from the ground level to an angle of 50. Find the maximum height. And then find the magnitude and direction of the velocity 0.5 seconds later. If you do it very well, you should get the maximum height yourself. Please try it. You can pause the video to try, and I'm sure when you do it very well. Okay, I will give the solution to the last question in my next video. Thank you very much.